Hi and welcome back to the course. In this video we're going to look at passing functions as parameters. This is a much more advanced concept that we can use a lot when creating nice readable code and also when we want to generalize code a lot. We will use it later on in the course. Right now it may look like it's not very useful, again just like the last stuff we looked at, but nevertheless the complete Python refresher that I want for you has to cover this stuff. So I'm going to create a method called methodception. And it's going to take in a single parameter. But this parameter is not something that we can add or multiply or print. It is a method that we're going to call. So add to numbers is going to be another method. And that's going to return 35 plus 77. Now, what we can do is print methodception of add two numbers. Now, here's the thing. Normally, when we call a method, we would put in opening and closing brackets at the end. But in this case, we're not going to put them in. What we're going to do is we're going to pass the method as a parameter to methodception, and methodception is going to run that method. So we are not going to run it here, it is going to run up here. And then that's going to run and return 35 plus 77. So essentially what we're doing is we're passing a function, a method, as a parameter to another method. If we run this code, we get 112, which is the sum of 35 and 77. So this works as you would expect. Now here's something else that we can do, which is much more interesting. We can do something that's called a lambda function. A lambda function is an anonymous function. So we can do print methodception lambda 35 plus 77. So we get the same value back, but now we are calling this function is what we're passing into methodception, and then that is running the function. So this function is exactly the same as this one, except it doesn't have a name. And lambda functions are always in one line, so you can't have them multi-line. So it's always in one line. Okay, so passing functions to functions, apart from being some sort of inception sort of thing, it's actually really useful. This is part of a style of programming or a paradigm called declarative programming or functional programming. They're both sort of similar, and declarative is probably part of functional programming. And it's especially useful when we want to work with data. For example, let's say we've got a list, 13, 56, 77, 484, something like that, and then we want to remove one of those elements. A way to do it would be to do something like my_list.remove, I think, 13, and that would remove the element 13. But say we wanted to remove all the elements that are even. We can no longer do mylist.remove 56 and then mylist.remove 484. It's starting to get long. If you have a lot of elements, that gets really complicated. So I would not recommend that you do that. Instead, what you would do is you would use a Python built-in method called filter. And what this method does is it allows you to keep only some values. So this method takes in a function and also an iterable. So we're going to create the function first, lambda x. X is not 13, and the iterable is mylist. So we're going to print this out. Also remember, as of Python 3.5, whenever you call the filter function, you also have to surround it by list if you want it to come out in the form of a list. So what we're doing here is we're saying we're going to filter this list using this function here. So let's run it and see what comes out. And as you can see, what comes out is 56,77,484. So basically all of the numbers that were not 13. Okay. To further explain lambda functions, we can do things like this. Lambda x multiplied by 3, 5. Here we define a lambda function with one parameter, x. And the body of the function is x multiplied by 3. So think of this function essentially as def and then what we're doing is f5. These two are identical. There's no difference between them. So let this be a bit of a food for thought sort of thing. What this will print out is 15, and what this will print out is 15. It's identical. You wouldn't normally do this. You would use lambda functions more frequently in things like filter, because it makes a bit more sense. However, we've got here a function that essentially says not 13, so we could create that function not 13, return x is not 13, and then we could replace that here, not 13. Okay, so this is something we can do. We do not have to use a lambda function. We can use a normal function if we prefer. And this works in exactly the same way. As you can see, we get the same output back. So what we're doing here is we're running this function against this list and filtering out all those values, or rather keeping only all those values that match this condition. So we're keeping all the values that are not 13. Filter is pretty neat, and it essentially goes against list comprehension. You could do the same thing with list comprehension. It would be something like print x for x in my list if x is not 13. So it may be slightly simpler, and many Python programmers would rather use this. They would rather use the list comprehension. However, I mentioned in the list comprehension lecture, the list comprehension is quite unique to Python and to a couple other programming languages. However, the concept of filter is present in many programming languages. So if you program with other programming languages, or you work with people who program with other programming languages, you probably want to stick to filter because it is more familiar to people. The performance is more or less the same, or maybe slightly better for list comprehension. So if performance is an issue, then you will want to investigate which one is better and use that accordingly. But apart from that, it's up to your preference really and the people around you. In some cases, people use filter, and in others will use list comprehension. I tend to prefer list comprehensions, but then I also do a lot of JavaScript programming, and they don't have list comprehensions, so we're stuck with using things like filter. Then again, nothing is perfect in this world, so not everything can be Python. Without further ado, I'll see you in the very next video.